Hey everyone, welcome back to Daily LeetCode channel. Today we're looking at a classic linked list problem from LeetCode. Problem 19, remove nth node from end of list. And this one is marked as medium difficulty. Here's the problem statement. You are given the head of a linked list, and your task is to remove the nth node from the end of the list, and then return the updated head. That's it. You're not removing the nth node from the front. You're removing it from the end, which means we need to think backwards through the list, even though linked lists normally move forward only. It's a very popular interview problem, and it also tests whether you understand how to use pointers efficiently. All right, now that we know what the problem is asking, let's move on to the examples to understand it even better. All right, now let's take a look at the examples provided in the problem so we can understand exactly how this works. Example 1, input. Head equals 1, 2, 3, 4, 5. N equals to 2. Output 1, 2, 3, 5. Here's what this means. We have a linked list with the values 1, 2, 3, 4, 5. We are asked to remove the second node from the end. So let's count from the back. 5 is first from the end. 4 is second from the end. That means the node with value 4 must be removed. Once we take that node out, the updated list becomes 1, 2, 3, 5. Example 2 input. Head equals 1, n equals 1. Output empty linked list. This time the list has only one element, 1. We're asked to remove the first node from the end, which is the only node. So once we remove it, the list becomes completely empty. Example 3 input. Head equals 1. 2, n equals 1. Output 1. This list has two nodes, 1, 2. We need to remove the first node from the end, which is the node with value 2. After removing it, we're left with just 1. These examples make it clear that depending on the position and the size of the list, the node removed can be anywhere, even the head itself. Now that we understand the examples, let's move on to the solution and see how to remove the nth node efficiently. All right. Now let's walk through the solution step by step and understand exactly how this code removes the nth node from the end of the linked list. Here's the code we're analyzing. Step 1. Handle edge cases. The code first checks if the list is empty or if the list has just one node. In both cases, removing the only node results in an empty list, so we return none. Step 2. Count the total number of nodes. Here we are simply counting how many nodes are in the entire linked list. We start with count equals 1. We move p all the way to the last node. Every time we move forward, we increase the count. After this loop, c holds the total number of nodes. P is at the last node. Step 3. Check if we need to remove the head node. If the node to remove is the first node in the list, that means the nth node from the end is actually the head. For example, if the list has 5 nodes and n equals 5, remove the head. So in this case, we simply return head next. Step 4. Find the node just before the one to remove. Here's what we're doing. We want to stop one node before the node that should be removed. C minus n gives the position 0 based of the node to be removed. So C minus n minus 1 gives the position of the previous node. We move pointer p until it reaches that previous node. Step 5. Remove the nth node. This line skips over the unwanted node. P next is the node to remove, so we rewrite it to P next, next. This effectively deletes the nth node from the end. Step 6. Return the updated list. The head hasn't changed unless we remove the head earlier, so we simply return the original head pointer. Final explanation summary. So overall, this solution works in 2 passes. Pass 1. Count the total number of nodes. Pass 2. Navigate to the correct spot and remove the target node. It's simple, clean, and follows a direct approach without using extra pointers like the classic 2-pointer technique. This method runs in over n time and uses over 1 extra space, making it both efficient and easy to understand. All right, now that our solution is ready, let's go ahead and run the code. Running the code, perfect. All the sample test cases passed. Now let's hit that submit button. And there it is, accepted. All hidden test cases passed successfully. Our logic worked exactly as expected, and the solution ran efficiently. If you found this breakdown helpful, Make sure to like the video, subscribe, and turn on the notification bell so you never miss the daily LeetCode explanation. Thanks for watching, and I'll see you in the next one. Happy coding!